In this next unit, we are going to be working with formulas. And in order to use these formulas, we have to make sure that the angle that we are given is measured in radians. So if they give us something in degrees, we have to convert it to radians first. So we're going to be looking at linear and angular velocity. And the best way to describe or to give you an idea of what linear and angular velocity are is to think about a carousel. So in a carousel, a lot of us rode the horse or the multiple horses that were on there. So think about the 4 different rows that those animals sit in a carousel. You've got the ones that sit in the outer row. So as the carousel starts turning, notice that they're all rotating that 360 degrees in the same amount of time. So their angular velocity is the same because they're traveling the 360 degrees at the exact same time. But think about if we were to stretch that circle that each row of animals is traveling into a straight line. You would notice that the animals in the outer row has a longer line than the animals that are inside the inner row. And that means that the linear speed of the animals in the outer row are greater than the linear speed of the animals that are in the inner row. Okay, this is just one formula used to find angular velocity. It's the most popular formula used. I've went ahead and defined what each of those variables represent, and I included what the unit of measurement would be for each of those. For linear velocity, these are just 3 of the formulas. There are even more formulas for linear velocity, but I've listed 3 of our most popular ones here, and I've also defined what these variables represent, including their unit of measurement. Some of the variables listed here in these formulas are also listed here. So between these 2 lists, you should see what each of the variables represent and how they are measured. So we are going to use these formulas to help us find the missing variable. So on number 1, we have W equals theta over T. That's the formula that we're going to use to help us complete this top table. So they give us 2 of the variables. We have to find the third. So on this first one, we have W given to us and time given to us, T. So we're going to plug those into our formula. So we've got W equals theta over T. So that's the formula we're going to be using. W is 4 pi over 9. We're trying to look for theta, so we're going to leave theta in place, and then we're given time to be 5. So we have this proportion right here. Remember, to solve a proportion, you just cross multiply. So up here, I'm going to do that. So for this first one, if I multiply the 9 and the theta, I get 9 theta. If I multiply 4 pi and 5, I get 20 pi. And then just divide by 9, and we get that theta equals 20 pi over 9. This cannot be simplified, so 20 pi over 9 would be the measure of that central angle for that particular problem. For the second part of that table, we can see that the blank is where W is. So we are going to plug in pi over 3 for our theta, and 12 for our time. So I'm going to move up here so we have the W that we're trying to find. Theta is pi over 3. That's going to be divided by 12 for our time. We've seen these were called complex fractions. This is the same as a division problem, just written vertically instead of horizontally. So this is the same thing as saying pi over 3, the numerator, times the reciprocal of the denominator, which is 1/12. So now if we multiply pi and 1, we get pi. If we multiply 3 and 12, we get 36. So pi over 36 is our angular velocity when given a central angle and the time. And then the third blank in this table, you can see that the blank is in T. So using our formula, we've got W, which is 2 pi over 5, equals to 5 pi over 8 divided by T. Again, this right here is the same thing as saying 5 pi over 8 times the reciprocal of t, which is 1 over t. So if I multiply those together, I get 5 pi over 8t. So now we've got this proportion here, so we can cross multiply. So if I multiply this diagonal first, 2 pi and 8t, I get 16 pi t. And then when I multiply the other diagonal, I get 25 pi. So my last step is to divide by 16 pi to get t by itself. So you can see here that their pi on the top, the pi on the bottom can cancel. 25 over 16 cannot be simplified. So 25 over 16 would be our answer. So it's just plugging into a formula and then using your Algebra 1 skills to solve the equation. On the second example, we're using the formula V equals RW. Same thing, where the blank is what we're trying to find. So on the first one, the blank is in V. So we are going to plug in for V here. So we've got, I'm going to move over here, V equals, we've got a radius of 10 times an angular velocity of 3 pi over 2. So when we multiply, we get 30 pi over 2. And 30 pi over 2 can be simplified to 15 pi. So that is our linear velocity. On the second one of that table, our missing variable is the W. So plugging into the same formula here, V is 15 equals R, which is 3. Looking for W. Obviously, we just have to divide by 3. 15 divided by 3 is 5. So our angular velocity is 5 radians per second. And then finally, on the third one, the blank is on the R. So plugging this in here, we've got our velocity of 18.276 equals R, which we don't know, times W, which is 2 pi over 3. Remember, anytime you want to move a fraction from the variable, you multiply by the reciprocal. So we have the 18.276 times, and if we flip this fraction, it's 3 over 2 pi. Now, because we were given a decimal in this one, our answer is allowed to be a decimal. So you're going to need to use your calculator on this one. So we're going to take the 18.276, and we're going to multiply that by 3. In your calculator, you should have 54.828. And then we're going to divide that by 2 pi. And you should get an answer of approximately 8.726 for your final answer on that one. And then finally, on this bottom one, we are going to use this formula S equals RWT. This is yet another formula that we could be working with. Remember, S is your arc length, radius, angular velocity, and time. So we've got 4 variables. 3 of them are going to be given to you. And so you're going to find the missing one. So on the first one, you can see that our missing one is on S. So we're given R, W, and T. So we're going to plug those in here. So let's see. S is what we're looking for. R is 7 times W, which is pi over 4, times T, which is 4. No decimals were given to us, so we're going to just leave the pi as a pi. So 7 times 4 is 28. So we have 28 pi, and that's all over 4 because that's the only number in the denominator. And then, of course, 28 divided by 4 is 7. So our S is 7 pi. On the next one, you can see that R is the one that's missing. So we're going to use the same formula, and we're going to plug in the 3 pieces of information that you see here to find it. So S is 2 pi over 3. R is what we're trying to find, times W, which is pi over 6, times T, which is 6. Same thing here. With this here on the right-hand side, you have 6 pi over 6. Well, the 6's can basically cancel, so you're just left with R times pi. And in order to get this r by itself, we have to divide both sides by pi. And we saw this scenario earlier on an example. So that's the same thing as saying 2 pi over 3 times the reciprocal, which is 1 over pi. So then our pi's can cancel. So we're just left with a 2 on the top and a 3 on the bottom. So our answer for our radius is 2/3. On the third one, W is blank. So using the same formula, we've got S, which is 3 pi over 5, equals R, which is 8, times W, which is what we're looking for, times time, which is 12. If you take 8 times 12, that's 96. So right now we have 3 pi over 5 equals 96W. And to get the W by itself, we've got to divide by 96. To shortcut what we did on that last problem, if we're dividing this by 96, it's the same thing as multiplying the denominator by 96. So if you put 96 times 5 in the calculator, you get 480. So we have 3 pi over 480, and that's what W equals. You can try plugging that into your calculator to see if it simplifies, and it does. It simplifies to 1 pi over 160. So that would be the measure of W on that problem. And then finally, we've got T here at the end. So using the formula, S is 2 pi over 5. R is 5, W is 2 pi over 7, and we are looking for T. Same thing here, we can combine all these together. And see, we have the 2 pi over 5 equals 10 pi, I can write here, T over 7. We've got a proportion here, so we can cross multiply. So if I multiply this diagonal here with the variable first, I get 50 pi T. And if I multiply this diagonal here, 2 pi times 7, I get 14 pi. So then all I have to do is divide by 50 pi and simplify this. You can see that the pi's can cancel. In your calculator, you can put 14 over 50, and you get 7 over 25. So our answer is 7 over 25. So again, it's just plugging into a formula and solving the algebraic equation from there.